18 minutes. That's how long the ground remained quiet in Xinghai County before it broke a second time. Magnitude 5.7 and then magnitude 5.8. What is going on in the world with these double earthquakes that we keep seeing popping up everywhere in such a short time frame? We remember Venezuela, 2 earthquakes within 39 seconds in the higher magnitudes than this. But here, China, magnitude 5.7, then 5.8, same depth. Same few kilometers and miles of rock, and the part that almost nobody's saying out loud right now, this exact spot has already produced a strong earthquake with consequences, a magnitude 6.6. So are these foreshocks? What can we expect? Why is this so weird? So in the next few minutes, I'm going to show you 3 things that will blow your mind. So we have the beach ball of the first earthquake, the fault fingerprint, what it actually says about the ground that moved, why calling the 5.7 a foreshock is technically correct and scientifically misleading, and the 5 specific signals that would tell you this is turning into something bigger. So stay for the end of that last one. It's the one that seismologists are actually watching right now. So what happened? Here are the raw numbers from the Chinese network that we keep coming in right now. First shock, magnitude 5.7, 10 kilometers deep, that's about 6 miles, 11:16 in the morning, Beijing local time. Only 18 minutes later, magnitude 5.8, same depth, within a few kilometers and miles of the first. Now, 2 earthquakes that close in space, that close in time, at that depth. Those are not 2 separate events that happened to share a morning. That's one fault system, I want to make that clear, guys, that is rupturing twice. And then 6 miles, 10 kilometers, that's shallow if they keep the depth at that level. So shallow, that we know for sure. And that's important because, maybe more important than the magnitude, because a shallow 5.8 shakes the surface far harder than a deep 6.5, for example. So there's almost nothing between the rupture and the villages on top of it if it's so shallow. So was the 5.7 a foreshock? For now, it looks like it because we only have 2. So technically we can say yes. The definition is brutally simple though. If a bigger earthquake happens nearby afterwards, everything before it obviously becomes a foreshock, right? So 5.8 was larger, it was close. So the 5.7 gets relabeled, it's the foreshock right now. But here's the problem, guys. There is a problem. The difference between them is basically 0.1. Doesn't sound like much. It is a lot. The 5.8 is a lot bigger than a 5.7, but still, this is within normal magnitude uncertainty, so we cannot be sure which one was really, really bigger, right? Different agencies routinely disagree by more than that. So calling one the foreshock and calling one the main shock is basically drawing a line that the data actually cannot support right now. So honest description is, we have to say it's an earthquake doublet. 2 roughly equal earthquakes side by side, really at the same location. And now the question that everyone wants answered, are both of these foreshocks to something bigger? That's the important thing. Well, nobody can tell you, not me, not the USGS, not the Chinese network. A foreshock is only ever identified after Shizzy has hit the fizzy, unfortunately, after the big one, right? So that's not an evasion. That's basically the physics that we have to deal with. So, but what we do have is a baseline. Globally, we can say that roughly 5% of earthquakes are followed by a larger one nearby within a week. And we have seen that recently in the case of Venezuela, only 39 seconds, not 39 seconds. What am I saying today? But 5%, guys, that's worldwide average. That is, of course, not a forecast here for Xinghai, but it's not zero either. I just mentioned we've seen it happen. And so what did the rock actually do here in the first magnitude 5.7? The thing is, 5.7 gave us a clean solution how the fault moved. We see that in the beach ball, and it's unusually unambiguous. So 96% double couple in plain English. This was an ordinary tectonic fault movement, basically rock sliding past rock. So that confirms it wasn't magma, it wasn't volcanic, it wasn't anything exotic. And that matters because when a sequence like this hits, and especially hits the internet afterwards, right? The exotic explanations, they arrive within an hour and the data closes that door immediately. So it was nothing like of that sort. The motion was overwhelmingly horizontal, so it was a strike-slip earthquake. The two sides of the fault basically grinding sideways past each other with a little bit of a whisper of some vertical movement. Compression running roughly northeast-southwest, extension roughly northwest-southeast. That's exactly what you would expect in this part of the world. India is still, the Indian plate, driving north into Eurasia. Tibet can't go up forever, so it goes sideways. This earthquake is basically that process in miniature. And yeah, just happened right now. So the question is, which fault did this? Here's, where at first the easy answer shows up, and where the easy answer might be wrong, it's probably wrong, because most coverage will say, yeah, that's the East Kunlun Fault, and then they move on. That fault is the famous structure. It's the one that has a Wikipedia page, but I don't think that's it. These earthquakes struck near the Eastern Kunlun system right around 99.5 degrees east. And at that longitude, the major left lateral Kunlun Fault makes a significant bend. And that is important because that changes things. It's basically in that bend, it's handing off from one segment to the next. And bends are especially there where fault systems get messy, guys. So you don't get one clean line when there's a bend. So you get the main east-west trace, parallel splays running alongside of it, and we have north-south to north-northeast structures that are cutting straight across this as well. And it's one of those cross-cutting structures, like a near north-south to north-northeast local fault that I think broke here. So not the big headline fault, the one that's running across this main fault might be the culprit. So we do know scientifically these branched out faults, if the big one is locked and loaded, they can trigger the big one. Also the case for the San Andreas Fault, for example, right? So what we need to wait for are the relocated aftershocks, because they will confirm it or not. But there's a reason I'm calling it now, and it's what happened here 26 years ago in the year 2000. That is very, very important. September 12th, 2000 to be precise, magnitude 6.6 in Qinghai. Location roughly 35.3 north, 99.5 east. That is only about 8 kilometers, so roughly 5 miles from where today's double earthquakes struck. So given the location uncertainty of that area, that is basically effectively the same source region. We can confirm that. And interesting, the research on that magnitude 6.6 event doesn't put it on the main east-west trace either. It puts it on a north-northeast oriented fault that is running straight through this epicentral region that we're dealing with right now. So same spot, same orientation. So we're almost certainly watching the structure the same structure that produced a magnitude 6.6, doing it again right now, smaller. Foreshock question mark, because here's what the 6.6 did. 5 people injured in Wenquang Township alone, 75 houses collapsed, 948 houses were seriously damaged, at least 3 magnitude 5 aftershocks followed shortly after. So this is the damage that can be done here. So read those numbers again. 75 houses collapsed and nearly 1,000 houses damaged from a 6.6. So that's not a statistic about earthquake size, right? This is a statistic about building shock. So older masonry and adobe construction, shallow rupture plus mountain terrain, the same combination is still sitting here today. So this is not some quiet corner on the map that is suddenly misbehaving. I want to make that clear. This is basically we can call that a source region with a demonstrated ability to produce at least a magnitude 6.6. And this thing is waking up again with a double earthquake, we have to say. And now you want to ask, well, wasn't there another one just recently? Yeah, you're right to remember it. June 16th, magnitude 6.3 at Haiqi with strong aftershocks, including 5.2, several, but that is 446 kilometers. That's 277 miles northwest from this epicenter. And the 6.3 was a predominantly reverse fault rupture, different mechanism, different structure, ground moving up and over, not just sideways. So, but, here comes the but, both are children of the same continental collision that is happening there. But there's no evidence that what happened in June has triggered right now what happened in July across that long distance, that they are apart. So don't let anyone sell you on that connection. This is just not true. What can actually happen now? That is the interesting part. So most likely, lots of smaller aftershocks with a rate gradually declining. But at 10 to 12 kilometers deep, 5 to 7 miles, even magnitude 3s and 4s will be felt hard. I want to make that clear because it's so shallow. And then given the structures that are on top of there, right? What is quite plausible, what could happen, another shock around 5.0 to 5.8. Because 2 near equal ruptures can mean that the fault is stepping between adjacent patches instead of finishing cleanly in like one go. So another thing that I think is possibly possible but less likely if that we get a magnitude 6 now. We know it's physically capable. Year 2000 has proved it. Another thing that is possible but not currently indicated would be a magnitude 7. But that would have to involve a way longer stretch of the Kunlun system. That system has produced magnitude 7 plus events, including our roughly 7.5 west of here in 1937. But 2 magnitude 5s do not prove that a magnitude 7 plus is loading, but it's possible. Absolutely. But this thing here is deep inland, so we don't have to worry about tsunamis or anything. It's rockfall in this area with the mountains. Landslides on slopes that are already loosened by the first 2 shocks, and then if another shock comes, doesn't even have to be bigger. Road damage, cutting off access to exactly the villages that would need the access to have help coming in. And then, of course, the older masonry and adobe buildings that could fail if another strong shock arrives. I would watch out for 5 signals that then would raise my concern level. So more magnitude 5s would start migrating, for example, along a clear line. 2, the activity spreads across tens of miles instead of staying like tightly clustered like it is right now. And point number 3, if we look at the second earthquake mechanism, if that matches the first, so that would confirm repeated slip on the same structure. 4, we see aftershocks that begin aligning along the longer east-west Kunlun trace. And number 5, Chinese agencies report acceleration instead of the normal declining aftershock pattern. If any of those happens, the conversation changes. But right now, we just have to wait and see and think that this was it so far. I'll keep you updated, guys, but check out this video here in the end screen. Strange and amazing at the same time. So it's worth your while. You will like it. See you here in a second. Bye-bye.